Okay, and to start our final segment for today, there is also the question of how to convert compound units. Compound units, again, are units that are made up of two or more other units, two or more simple units, like, for instance, miles per hour. Miles per hour is a speed. If you travel a certain number of miles for each passing hour, that would be your speed. So for instance, 65 miles per hour just means that you travel 65 miles for each passing hour. This is a compound unit because it's made up of both miles and hours. And you might have to convert a unit like that in a situation where you have to convert both the unit in the numerator and the unit in the denominator. For instance, miles per hour is the most common unit for measuring speeds in the English system of measurement, but in the and kilometers per hour would be the most common in common everyday metric system. But in the SI system, the official unit for velocity is meters per second. Meters per second. So you have to change not only miles to meters, you have to change hours to seconds. And there is a certain process for doing that, where and it's simpler than you might think, but you just sort of have to keep track of what you're doing. Essentially, what we're going to do is we're going to change the two units, the unit in the numerator and the unit in the denominator, separately, one at a time. So we're going to convert miles to meters first, and then we're going to come back and convert hours to seconds. And we're going to do that sort of one after the other. And in fact, you don't even have to stop and start a new step. You can do it all at once, straight across, like we've been doing most of the conversions so far. So you have to, you still have to map out how you're going to do those conversions, though. So to go from miles to meters, I think the most sensible way would be if you look at miles and meters are both units of distance or length. And so if you look at the conversion factor here, we've got to say mile, well, we've got say miles to kilometers, right? We've got right here the relationship between kilometers and miles on the conversion sheet. So if we can go from miles to kilometers, then we can get the meters. Because meters, you know, a kilometer is just 1,000 meters. That's the meaning of the metric prefix. So we can go from miles to kilometers to meters. There are other ways to do this. You could go from, say, miles to feet to inches to centimeters to meters. For instance, that's just one of many different ways you could do it. But miles to kilometers to meters only has essentially 2 steps in it. So that is relatively easy. And then going from hours to seconds, we'd probably want to stop off at minutes, unless you know off the top of your head how many seconds there are in an hour. I've done stuff like this often enough that I know that I remember that number, but you probably don't. So you can go from hours to minutes and then minutes to seconds. What'll make this a lot easier, though, if you're going to convert the numerator unit and the denominator unit individually, separately, would be to rewrite the quantity given explicitly showing what's in the numerator, and what's in the denominator. So 65 mph or 65 mi/hr, I would write as 65 mi over hr. And you could put a 1 in front of the hours if you want. Also, just to be clear, this is 65 miles for every 1 hour that passes by. Okay, then this makes it clear which unit is in the numerator and which unit is in the denominator, so that you can make sure that units are canceling out for real when you want them to cancel out, and that they're not canceling out if you don't want them to cancel out. So what we're going to do in converting miles to meters is just go ahead and convert miles to kilometers to meters while ignoring the hours. Don't worry about it. The hours will still be here later when we come back for them. So we're going to end up basically leaving the hours the way they are, but we're going to change miles to kilometers in which case we could stop and write down the answer in kilometers per hour if we wanted to. And then we're going to convert kilometers to meters, in which case we could write down the answer in meters per hour if we wanted to. But we don't want that unit, so I'm not going to do it. And only then, when we get the top unit converted, will we come back and worry about the hours. Okay, so 65 miles per hour. First conversion factor between miles and kilometers. First of all, we know that miles are going to need to go in the denominator and kilometers are going to need to go in the numerator so that miles will cancel out. And then don't forget the numbers. The sheet says that there's 0.621 miles for every kilometer. Okay, so that's 1 kilometer for every 0.621 miles. Don't worry about doing anything with the numbers yet, because we're still looking at converting the units. Kilometers per hour would be the units that we would have if we stopped now and wrote down the answer. But that's not what we want, so I'm going to keep going. We're still going to ignore the hours, and we're going to convert kilometers to meters now. So we want kilometers in the denominator and meters in the numerator. And 1 kilometer is 1,000 meters. That's what kilo means. So now kilometers will cancel with kilometers. And if we stopped and wrote down the answer now, we would have a certain number of meters per hour. But again, that's not what we want. But we have got the top unit to be what we want it to be. So we're done converting the top unit. Now we have to worry about the hours. And this gets a little more complicated because hours is in the denominator. That means when the unit you're trying to convert is in the denominator, then that unit in the conversion factor has to go in the numerator, so it'll cancel out. And the unit that you want to go to has to be in the denominator because that's where we want seconds, seconds to be. It's in the denominator. Okay, so if we're going to go from hours to minutes, there's 1 hour for every 60 minutes. This way, hours will cancel. And if we stop now and wrote down the answer, we would have meters per minute. But that's not what we want. So there's one more step, minutes to seconds. Again, we're trying to cancel out minutes, which is in the denominator. So that unit has to go in the numerator for the conversion factor. There's 1 minute for every 60 seconds. Now minutes cancel, and we've got the bottom, the denominator unit to be what we want it to be, which is seconds. So now when we work out the answer, we're going to have units that are, well, the only units they haven't canceled out yet, meters in the numerator and seconds in the denominator. For the number, all we need to do is take 65 divided by 0.621, and that equals 104.669, blah, 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 times 1,000 equals, divided by 60 equals, divided by 60 again equals 29.07496869. And that's good, actually, because the general rule of thumb is that meters per second is generally about half the number of miles per hour. And this is, this is about 30 and that's 65. So that, yeah, that's about half. So that came out pretty much where we expected it to be. And obviously that's too many significant figures though. So looking at significant figures, we've got 65 is obviously 2. The conversion factor between kilometers and miles is between English and metric. So that is not infinite. It's 3 significant figures for the 0.621. Meters to kilometers, though, is metric, and so that's infinite. hours to minutes, hours and minutes are both metric and English. But anyway, 60 minutes being equal to 1 hour, that is a definition, so that's considered infinite also. And 1 minute being 60 seconds is also a definition, so that's also infinite. So it looks like 2 significant figures is what we're supposed to have here. That means we can use the 29, and everything from the decimal point on has to go. The first digit we're dropping is 0, which is less than 5, so the numbers before it can remain the same. So 29 meters per second it is. Okay, that's how you can do it step by step. This is a very useful and valuable thing to know how to do, because there are cases where you can't make any shortcuts around it. Like, for instance, if you have to convert a density from one unit to another or something like that. Actually, though, with speeds or velocities, there are shortcuts around doing it this way. Because if you notice, I mentioned before that the conversion factor sheet that I'm giving you for this class actually has conversion factors from one unit of speed to another. And so actually it is possible to convert from miles per hour to meters per second directly using one of these conversion factors, and you don't have to convert miles to meters and hours to seconds separately. The way you would do that, in that case, if you're going to do that, if you're going to use one of these conversion factors, then the way I would approach it would be write the units basically the way they're written up here, or the way they'll probably be written when I type them out, 65 miles/hour, and consider that to be your numerator over 1, the whole thing over 1. And now we're looking for something between miles per hour and meters per second. Let's see. Oh, there we go. There's meters per second, and there's miles per hour. There's meters per second also, and there's miles per hour. This one, I'm going to use the second one because it's easier, because one of the numbers is 1. So we're going to want miles per hour in the denominator and meters per second in the numerator, because this is the new unit in the numerator and that's the old unit in the denominator. And the sheet says 1 meter per second is equal to 2.237 miles per hour. Okay, 2.237. We'll note that the unit miles per hour and in the denominator of the conversion factor cancels with miles per hour in the numerator of the first term. So we end up with meters per second as our unit. And 65 divided by 2.237 is 29.05677.246. And some of the numbers got garbled there, but we're going to have to cut these digits off anyway. So it might look, again, at first glance, it might look to be different from the answer we got using the other method up here. But again, when you correct for significant figures, you'll find out that it's exactly the same. Because again, our limit here is going to be 2 significant figures. The 65 is still only 2 significant figures. The conversion between meters per second and miles per hour is between English and metric, so it's not infinite. It is 1, 2, 3, 4 significant figures. So 2 significant figures is the limit for our answer. So that's 2 and 9 can stay. Everything from the 0 on has to go. Since 0 is less than 5, the numbers before it can remain the same. And look what we got, 29 meters per second. So within the correct number of significant figures, these answers are exactly the same. This is a much easier way to do this kind of calculation for speeds or velocities, but Like I said, there are some cases where you might have to use this method, basically for any kind of compound unit that doesn't involve speed. Okay. So let's see, what else we still have to do in this chapter. Units raised to a power. Units can be multiplied together, as I said, and then what you end up with is just the unit raised to a power. So if you take inches times inches, you get inches to the second power, or square inches. If you take inches times inches times inches, you get inches to the third power, or cubic inches. And it works that way with other linear units also. Actually, you can do that with volume units too, but you normally wouldn't want to because volume units are already three-dimensional. So for instance, if we want to convert a volume of 135 cubic inches to cubic meters, okay, convert 135 cubic inches to cubic meters. What you can do in this case is, first of all, look at the volume sheet and see if it gives you anything useful. And actually it does. Notice this second unit here, cubic inches equals 16.39 cubic centimeters. We know from previous examples that 1 inch, going in one direction is equal to 2.54 centimeters. The way they get this conversion factor here, 1 cubic inch is equal to 16.39 cubic centimeters, is by taking 1 inch to the third power, which is equal to 2.54 centimeters to the third power. Because when you take a measurement like this with numbers and units and put it in parentheses with a unit or with an exponent outside the parentheses, that exponent applies not only to the unit, but it applies to the number inside the parentheses also. So when we say 1 inch raised to the third power is equal to 2.54 centimeters, the quantity raised to the third power, this 3 applies to the inches and it applies to the 1. Of course, 1 times 1 times 1 is just still 1. So basically what we're saying here is 1 cubic inch is equal to 2.54 to the third power cubic centimeters. And 2.54 times 2.54 times 2.54 is 16.39. So that's where that comes from. The fact that you can raise units to a power as well as raising numbers to a power. So actually using that helps us because let's see. We could use that. Actually, we could use this also. I'm going to use this one because that way it'll be consistent all the way across. So we have inches here, and that means we need inches in the denominator, and we need centimeters up top. And it's 2.54 linear one-dimensional centimeters for every 1 linear one-dimensional inch. And we need the unit in the denominator of the conversion factor to cross out with the unit in the numerator of the previous term. And it actually doesn't. This is regular inches. This is inches to the third power, or cubic inches. Well, you can make this cubic inches, but you have to cube everything else in that term also in order to avoid changing its value. We can symbolize that just by putting a 3 as the exponent outside the parentheses. Now, this is cubic inches, which will cancel with cubic inches. We don't want to cross out the 3 though, because that still applies to the centimeters and the 2.54. So when we multiply things out later, we're going to have to take account of that 3. But anyway, at this point, we have cubic centimeters as our answer. And now all we need is the conversion factor between meters and centimeters. Centimeters on the bottom and meters on top. And 1 centimeter is 0.01 meters. But again, it's cubic centimeters in the second term that we need to cancel out. So we need this to be cubic centimeters also. And the only way we can get this to be cubic centimeters without changing the value of the conversion factor is to cube the entire thing. Again, we put the 3 outside the parentheses. Now this term on the bottom becomes cubic centimeters, and it converts with cubic centimeters in the numerator of the previous term. But we want to leave the 3 there because it still applies to everything else that's left in the parentheses. And so if we multiply this out, we should get units of cubic meters, and the number will be 135 times 2.54 raised to the 3rd power, or you could take it as 135 times 2.54 times 2.54 times 2.54 if you want to do it that way. Doing it as 135 times 2.54 to the 3rd power, you can just use the parentheses, 2.54, use the caret to raise it to the 3rd power, and then close the parentheses, and then hit equals. And then you can multiply by 0.01 to the 3rd power. And again, I'd use parentheses around that, 0.01 raised to the 3rd power, close parentheses, hit equals, and you get 0.0022122254. Obviously, that's way too many significant figures. So let's see, 135 is 3. 2.54 centimeters per inch is between metric and English, so that's not infinite, it is 3. 0.01 meter per centimeter, though, that is entirely within the metric system, so that would be infinite significant figures. So it looks like 3 is what we're limited to for our answer. Remember, though, the zeros at the beginning of a number never count for significant figures. So we're looking at 2, 2, and 1 after the first 2 zeros. That's 3 significant figures. Everything from the 2 that comes right after the 1 has to go. So the first number we're dropping is a 2. That's less than 5. So the numbers we're keeping can all remain the same. So 0.0221 cubic meters would be your answer, or 2.21 times 10 to the minus 3. Okay, so that's how you can basically do that kind of thing. So combining this with combining how to convert compound units from what we did up above can be useful in converting densities. The density of osmium is, oh, and also one thing, I think I mentioned it during class, but it can be useful in cases like this where you're dealing with length units to the 3rd power. When they set up the metric system, they did certain things deliberately. They set it up so that 1 cubic centimeter would be the same as 1 milliliter. And 1 cubic decimeter, that's 1/10 of a meter, or 10 centimeters. So a decimeter would be basically this long here, 10 centimeters. If you have a box that's 10 centimeters on each side, that's the same as 1 liter. Okay, so these are important relationships to remember, because these are not These are not given on the table of metric prefixes, and they're not given in the conversion table either, because they're metric units, and the metric system is simple enough. They just kind of tend to assume that you remember that kind of stuff. So be sure to remember those, because they can be very convenient in converting volumes. Anyway, the densest of all the chemical elements is called osmium. It's a very, very heavy metal, has a density that's about 22 grams per cubic centimeter. That's, for reference, that's almost twice as dense as lead. And you know how heavy lead is. So what would that density be in units of pounds per cubic foot? Or in other words, if you had a cubic foot of osmium, a box of osmium, a solid block of osmium that's 12 inches on each side, how much would it weigh? This is an interesting question because of the number you end up with. 22 grams per cubic centimeter may not sound like very much, but a cubic centimeter is only like this, and at 22 grams is almost an ounce. That doesn't sound like much, but that's actually a lot of stuff to fit in such a small space. So we can do this, and what this means is, first of all, you want to think of it as 22 grams over 1 cubic centimeter. And this has to become the number of pounds over 1 cubic foot. So we have to go from grams to pounds. And let's see, using our conversion factor here, that's a mass. We can do that in one step, grams to pounds. And then we have to go from centimeters cubed to feet cubed. Let's see if we have anything here. Oh, there we go. We can do that in one step also. 1 foot is 30.5 centimeters. And then when we use that conversion factor, we're just going to have to remember to raise it to the 3rd power, because we're actually looking for cubic centimeters to cubic feet. So we start with 22 grams over 1 cubic centimeter. Again, like before, we're going to convert the unit on top first, and then we're going to come back and convert the unit on the bottom later. So we're going to convert grams to pounds. That means we want grams on the bottom of the conversion factor and pounds on the top. And it says there's 1 pound for every 453.6 grams. So now at this point, grams should cancel out, and we would have pounds per cubic centimeter if we wanted to stop and write down the answer at this point. We've got the unit we want in the numerator. So now all we have to do is come back and fix the denominator. In the denominator, we've got cubic centimeters. We don't want cubic centimeters. We want cubic feet. Okay, so we can go from centimeters to feet directly for the conversion factor. We don't have a conversion factor that would directly take us from cubic centimeters to cubic feet. So what we're going to have to do is use the conversion factor for centimeters to feet. Okay, 1 foot is 30.5 centimeters. We want centimeters to go on top because that's where the cubic centimeter is, and we want those eventually to cancel out. So it's 30.5 centimeters for every 1 foot. But because this is cubic centimeters, we have to make this cubic centimeters in the numerator over here. And in order to do that without changing the value of the ratio, we have to cube the entire thing. So we write the 3 outside the parentheses. That means the 3 applies to everything inside the parentheses. So this is now cubic centimeters, which can cancel with cubic centimeters way back at the beginning in the denominator. And when we take the units, or when we find our final answer, our units are going to be the units they haven't canceled out, which would be pounds per cubic foot. mathematically, all we need to do is take 22 divided by 453.6. And that equals this number. And then we need to multiply by 30.5 3 times, or 30.5 raised to the third power. So that would be taking this number times parenthesis 30.5 raised to the third power, close parentheses, and hit equals. And we get 1376.097, and it goes on, but I'm going to cut it off there because we're already past the significant figures we're going to be allowed. All right, so now to look at significant figures. 22 grams per cubic centimeter, that's 2 significant figures. 1 pound for every 453.6 grams, that is between English and metric, so that is not infinite, that is 4 significant figures, 1, 2, 3, 4. 30.5 centimeters per foot is also between English and metric, so it's not infinite, that would be 3 significant figures. So we're only allowed 2 significant figures in our answer. So that's the 1 and the 3. Everything from 7 on has to go. 7 is greater than 5, so that means the 3 has to become a 4. And we're also dropping 2 digits before the decimal point. So to maintain the magnitude of the number, we have to fill those in with zeros. But don't write the decimal point, because if you do, this number would become 4 significant figures. Remember, zeros at the end of a number count if there's a decimal point. If there isn't a decimal point, they don't count. Or they may or may not count, but we assume that generally, to be safe, we assume that they don't. So 1,400 pounds per cubic foot. If you think about that, 1,400 pounds, it's probably the weight of, say, an old school Volkswagen Beetle, you know, back like in the 60s when the engine was in the back. They weighed probably about 1,400 pounds. That much mass is in a space of 1 cubic foot for osmium. You know, a box that's 12 inches on each side. So this length on each side, a sheet of paper is 11 inches. So think of something that's maybe a box that's a little bit longer than a sheet of paper on each side of osmium, weighs as much as an old school Beetle. That is a lot of stuff packed into a very small space. And that is osmium. Okay, well, I'm over time on this video too, so I'm going to have to cut it off there. This is effectively, there may be 1 or 2 little details I want to cover on Tuesday, but I'm going to call this the end of this first chapter. And so the homework assignments, the homework problems from chapter 1, I will collect those on Tuesday, and then we can start chapter 2. Okay, so I'll see you then.